Okay, with this lesson, we're going to be actually applying what we've learned about quadratic equations to some word problems. We're going to do some geometry and consecutive number problems. Okay, let's start out with the geometry. Number one says the width of a rectangle is 6 meters less than its length. So therefore, let's draw our rectangle. And it says the width is 6 less than the length. So if the length is x, then the width is 6 less than that, x minus 6. Always identify those variables, your unknowns, first. The area of the rectangle is 112. Now, if you remember how to find the area is equal to, let me scroll back up. The area is equal to the length times the width. Since the area is 112, that means that 112 is equal to length times width, which is x times x minus 6. Now, this is going to be a quadratic equation. Once we find the solutions, then we're done. So let's see if we can figure out what x is. Let's distribute to get rid of the parentheses. That'll be x squared minus 6x is equal to 112. Let's move everything to one side. X squared minus 6x minus 112 is equal to 0. Then you have all your different options for how are we going to solve this. Are we going to factor it, which is always the best method if we know how to factor? Are we going to use completing the square, which is a good option here because you have the 1 and the even number? If not, are we going to use our quadratic formula? So let's try to factor this, which I believe this will be factorable. So two sets of parentheses, x and x, adds, multiplies, and you get a negative 14 and a positive 8 is equal to 0. So therefore set each equal to 0, and you're going to find out that either x is equal to 14 or x could be negative 8. Now we've got to remember our domain. We've got to remember what in the world is x. X is a side length. A side length of a rectangle. A side length of a rectangle cannot be a negative 8, so therefore here's your solution. So the dimensions of this rectangle, which is what they're asking for, the x will be 14, and that's in meters, and the x minus 6 will be 14 minus 6, because everywhere you have an x, you're going to put a 14 in. 14 minus 6 will be 8. So this rectangle is a 14 by 8 meter rectangle. Number two, the length of a rectangle is one more than twice the width. So let's draw our rectangle again. And it doesn't matter which one you let be length and width. If this is the width and the other one's the length, it says the length is one more than twice the width. So if we let this be our width, then the length will be one more than twice that width. So therefore, there's our dimensions. The area is 300. Again, area is length times width. When I do length times width, when I multiply these two together, it's going to give me the area, which is 300. And you have, again, a simple quadratic equation. Distribute the x, that's going to be 2x squared plus x equals 300. Move everything to the same side, that'll be 2x squared plus x minus 300 is equal to 0. Now you can use your, you can use your discriminant to find out if this is factorable by seeing if you have two rational answers, which something when you plug into the discriminant that you know the square root of, but this is going to be factorable. However, we are going to have to use bottoms up, or slip and slide. So let's move the 2 to the end, and you get minus 600, two sets of parentheses. And this is a tough one. It's actually going to be x and x. That'll be a positive 25 and a negative 24. That would have been tough to come up with. The number that you moved, we now divide by. And that will be a 2x plus 25 and an x minus 12 is equal to 0. Set each equal to 0. And you're going to get that x is negative 25 halves, or x is equal to 12. Again, x is a side length of a rectangle, so it can't be negative, but x can be 12. So when you plug it in, this x value is 12, and this is actually in feet. So 12 feet, and this will be 2 times 12, which is 24, plus 1, which is 25 feet. So your dimensions here will be a 12 by 25. Number 3 says the dimensions of a rectangle can be expressed as x plus 6 and x minus 2. So there's your side lengths. The area is 65. So to find the area, you're going to do length times width. So length times width is equal to 65. Now let's simply solve the equation. We're going to have to distribute because this does not equal 0. It'd be so nice if this was equal to 0, then we know the answers, but it's not equal to 0. So we are going to have to distribute. I'm going to go ahead x squared, and I'm going to combine my middle terms as I distribute. Negative 2x plus 6x would be a positive 4x. 6 times negative 2 would be negative 12 equals 65. Move that 65 over, you have x squared plus 4x minus 77 is equal to 0, and this is very factorable. X and x adds, multiplies would be a positive 11 and a negative 7. So your two answers would be a negative 11 or x equals 7. And again, since x is the side length, well, let's see. X is not the side lengths. X plus 6 and x minus 2 are the side lengths. So if you were to plug in negative 11, though, the side lengths would be negative 11 plus 6, which is negative 5, so you do have to throw that out. Plug in 7, you get 7 plus 6, which is 13. And again, let's look and see what this is. It's in inches. So 13 inches would be one of our dimensions, and the other dimension would be 7 minus 2, which would be 5 inch. So this is a 13 inch by 5 inch rectangle. Number 4, the base of a triangle. Now we're dealing with a triangle here. Well, we don't have to draw it because we know we're dealing with the area of a triangle here. The area of a triangle is equal to 1/2 times the base times the height. So it tells you the base of a triangle is 7 less than twice the height. So let's draw the height, and let's draw or put a B for the base. So the base of a triangle is 7 less than twice the height. So we're revolving around this height. So we're going to let x be our height. The base is 7 less than twice the height. So let's find twice of the height, and 7 less of that would be minus 7. So therefore, the area of our triangle, which is 102, 102 is equal to 1/2 times the base, which is 2x minus 7, times the height, which is x. There's your equation. A couple of different ways you can do this. Let me show you a trick, though. To get rid of this 1/2, since it's being multiplied by everything over here, you can actually move it to the other side so you don't have to deal with fractions. Since 1/2 is being multiplied, let's divide by 1/2. Division by 1/2 is the same thing as flipping and multiplying. So that would multiply by 2 would be 204 equals 2x minus 7 times x. And you can go ahead and distribute that out. That'd be 2x squared minus 7x. Now you see it is a quadratic equation. Move everything to the same side. 2x squared minus 7x minus 204 is equal to 0. Again, I always like to see if it's factorable, so let's try our slip and slide. X squared minus 7x minus 408. So we've got to find two values that add to give you negative 7, multiplies to give you negative 408. And you can play around with that, but it's going to be a negative 24 and a positive 17. One way of doing that, well, there's several different methods, but you knew that the 2 times the 204, you could play around with those. You could double one, half the other, and try to come up with some method. But 24 times 17, we move the 2, so now let's divide by the 2. So therefore, you have 0 is equal to x minus 12 and 2x plus 17. Set each equal to 0, and you're going to get x is equal to 12 and x is equal to negative 17 halves. Since x, let's see if negative 17 halves is legal. X is the height. So therefore, the height cannot be a negative, so we're going to throw that out. So that means that the height must be 12. So we can write that right here. The height is 12 centimeters. The base would be 2 times 12, which is 24, minus 7, which is 17. Okay, number 5. Number 5 is a Pythagorean theorem question. It says the hypotenuse of a triangle, so it is a right triangle, is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Now, I want to point out something. The shorter leg is mentioned in both the other equations. That's going to be your unknown. So let's, well, we'll just write it like this. So you have 3 legs. You have the short leg. You have the longer leg. And then you have the hypotenuse, which is the longest of the 3 sides. So 2 legs and the hypotenuse. It says the shorter leg is involved in both, so that's going to be our unknown, our x. It says the hypotenuse is 1 foot more than twice the shorter leg. So twice the shorter leg, and then 1 foot more than that would be 2x plus 1. The longer leg is 7 feet longer than the shorter leg. So the shorter leg is x, so the longer leg will be x plus 7. Now the rule is, if you have a right triangle, a squared plus b squared is equal to c squared, or the leg squared plus the leg squared is equal to the hypotenuse squared. So therefore, now we have leg squared plus, make sure you put in parentheses, leg squared is equal to hypotenuse squared. Let's clean that up by foiling. That's going to give us x squared plus, to square this, the shortcut is square the x, multiply the 2 together and double it, and then square the 7 gives you 49. Then again, same thing here, the shortcut, square the first one, that's 4x squared, multiply them together and double it, and then square the last one. So there's your problem all squared out. Let's get our like terms together. Let's move our 2x squared over here by subtracting. 4 minus 2 gives you 2. Let's subtract off the 14, gives you 4 minus 14 is a negative 10, and subtract the 49 gives you negative 48. And now we have nothing on the left side, so it's equal to 0. Now the first thing I notice about this is every term is divisible by 2. So let's clean this up. Always, if you can, reduce these. So the right side is now x squared minus 5x and minus 24, and that's equal to the left side is now 0. So let's put it on the right side. This is factorable, so 2 sets of parentheses. X times x. Adds, multiplies will be a negative 8 and a positive 3, so therefore x is either 8 or x is negative 3. Now let's look and see what x is. X is one of the leg lengths. A leg length can't be negative, so therefore our x is going to be 8, so therefore let's change colors here. X is 8, so therefore x plus 7 will be 8 plus 7, which is 15. And 2 times, since x is 8, 2 times 8 is 16, plus 1 is 17. So the 3 legs, or the 3 sides of the triangles, are an 8, 15, and 17. Now on these problems, just a warning, they could do a follow-up question, or they could say, okay, what's the area of the triangle, or something like that, and you might have to go a little bit further with the question. Number 6 says the height of a rectangular prism is 3 feet. The length and width can be expressed as x minus 1 and x plus 4. The volume of the prism is 198. Now problem is length times width times height. So you have the height is 3, the length and width is x minus 1 and x minus 4. When you multiply those 3 dimensions together, it is equal to the volume, which is 198. So there we go. First thing I would do, instead of distributing that 3 times anything, I would divide it. The whole side's being multiplied by 3, so why not go ahead and move it over just to clean things up? The left side is going to get FOILed. X squared is x times x. Let's go ahead and multiply the 4 times x and the negative 1 times x and combine them. That gives you 4x minus 1x, which is 3x. And the negative 1 times 4 is a negative 4, is equal to, and this is equal to 66 whenever you divide it out. Move everything to the same side. X squared plus 3x minus 70 is equal to 0. This is factorable. That's very nice of them so far. Every problem has been factorable. X times x is x squared. Adds, multiplies would be a positive 10 and a negative 7. So therefore either x is negative 10 or x is 7. X cannot be negative 10 because when you plug it in, that would give you a dimension of negative 11 and a negative 6. That's not possible. So therefore, x has to be 7. So our dimensions, the value of x is 7. That answers the question. But this rectangular prism would be a 3 by 7 minus 1 is 6 by 7 plus 4 is 11. That's the dimensions of the entire rectangular prism. And you can check that out. 3 times 6 times 11 volume-wise would give you that 198. Next problem. It says Ken has a rectangular shaped vegetable garden that is 15 feet by 9 feet. He would like to increase the length and width by the same amount so that the new garden is twice the current area. Find the value of x to the nearest tenth of a foot. Now this one's a little bit tough. The current garden is a 15 by 9, and that's both in feet. So the current area, which you are going to need, 15 by 9 gives you a 135 square feet garden. He wants to change it to where the new garden has twice the area. So he wants a garden that has an area of 270 square feet. He's going to take the 15 by 9 and he's going to increase it by the same amount. So your new garden, instead of a 15 by 9, is now going to be a 15 plus x, and a 9 plus x is going to be the dimensions. To find the area, again, you simply multiply the new length and the new width. And you want that area to equal 270, and that's what we just found. So let's take and FOIL this out, and you could have wrote both of those as x plus 15 and x plus 9. Either way is going to be fine. Let's go ahead and distributive or FOIL this out. 15 times both. 15 times 9 is 135. 15 times x and x times 9 are going to be able to combine into a 24x. And then x times x gives you x squared. And we want that to equal 270. So let's rearrange these and write the x squared first, the 24x second. When you move the 270 over by subtracting, 135 minus 270 is now a negative 135. And there's your quadratic equation. I believe that's going to be able to be factored, or maybe not. I don't think there is anything that multiplies and adds to give you the negative 135 and 24. So therefore, we're going to have to use one of our other methods. Since this is a 1 and this is an even number, we could very easily use, let's use our completing the square here. Quadratic formula would also work, but since you have the 1 and the even, let's try completing the square. Step number 1, move over the 135. You now have x squared plus 24x, leave a space, is equal to 135. To complete the square, you take half of this and square it. You're going to add 144 to both sides. You now have, this will factor. It's going to be a perfect square. X times itself, what adds, multiplies will always be half of the 24. 135 and 144 is a 279. Next step, to get rid of a square, we plus and minus square root of 279. And to move the 12 over, we're going to subtract. Now let's talk a little bit about this answer. If I say, let's see, what are we finding? The length and width of this flower garden. If I tell you the length and width is going to be an extra negative 12 plus root 279, that makes absolutely no sense. Sometimes it is best to give a decimal answer. So you have two possible answers here. Negative 12 plus the square root of 279, or negative 12 minus the square root of 279. Let's plug this into our calculator, root 279, and let's actually get a decimal answer for this. The square root of 279 is about 16.7. So what you now have is negative 12 plus 16.7, which is 4.7. Or negative 12 minus 16.7, which is negative 28.7. So much better to give decimal answers there. So therefore, we can take our flower garden, and it says find the value of x to where we're going to increase it. We're increasing it by that amount. Well, it's going to be hard to increase it by an amount of negative 28.7. So again, we throw that answer out. So we're going to increase by an amount of 4.7. And another way you could give our answer, your original flower garden was a 15 by 9. It's now going to be a 19.7 by a 13.7. We're going to increase both dimensions by the exact same amount. So there is the value of your new flower garden, or the size of the new flower garden. Number 8, given the diagram below, the area of the shaded region is 59 square inches. What are the dimensions of the outside rectangle? So we've got to find x. So the area of the shaded region, let's talk about how you find the area of the shaded region. You have a rectangle with another rectangle cut out of it. So therefore, what we're going to do to find the area of just the shaded part, we're going to find the total area. And since it's a rectangle, to find that area is equal to, we're going to do length times width. We're going to multiply the two dimensions together. That's it. However, we don't want the total area. We want to take out this portion. So we're going to subtract from that, because that part's not included. We're going to subtract out the area that you get when you do x times x plus 3. Again, that's total area minus this area. Is going to give us, this is now the area of the shaded region, total area minus the white part. So let's, to find this area, let's go ahead and distribute this. X times everything will be x times 2x is 2x squared. Let's go ahead and combine negative 1x and 12x, so that'd be 11x. And then 6 times negative 1 is negative 6. Now, when you distribute here the x, make sure you distribute the negative with it. That's going to be a negative x squared and a negative 3x. Now, let's look back. The area of the shaded region is 59. So this is an example of the shaded. This is an expression representing the area of the shaded region. We know that this has to equal 59. So let's go ahead and include that. 2x squared minus 1x squared gives you 1x squared. 11x minus 3x gives you 8x. And then bring down the minus 6 equals 59. Let's move everything to the same side. So subtract the 59 over, gives you x squared plus 8x minus 65 is equal to 0. And that is going to be factorable. Two sets of parentheses. X and x adds, multiplies will be a positive 13 and a negative 5. So therefore, x is either equal to a negative 13 or x is equal to 5. Going back, can x be negative 13? Could you plug it in here and say this side length is negative 13? No, you cannot. So x must be 5. Now let's see what they ask us. What are the dimensions of the outside rectangle? So we've got to take out this x. We've got to put in the 5. 2 times 5 is 10, minus 1 is 9. So this is 9. X, which is 5, plus 6 is 11. And you could actually check this very easy. This x here would be a 5, and then 5 plus 3, this would be an 8. So the inside rectangle is a 5 by 8. The outside rectangle is a 9 by 11. If you find the outside rectangle's area, subtract the 5 by 8, which was 40, you do get the 59, which we were looking for. So the outside rectangle is a 9 by 11. Number 9. Find two, now we're working some consecutive integer problems. Find two consecutive positive odd integers such that the square of the large or the smaller integer added to 3 times the larger integer is 24. That sounds really tough, but here's all you have to do. Your first integer is x. The next consecutive odd integer, okay, consecutive means one right after the other, like 2, 3, and 4 are consecutive numbers. Consecutive odd numbers would be like 3, 5, and 7. So if x is the first one, then the next odd number will be 2 more than that, x plus 2. So there's your two positive odd integers. The square of the smaller integer added to 3 times the larger. Say it again. The square of the smaller added to 3 times the larger is 24. So we solve it and we know what they are now. That'd be x squared plus 3x plus 6 equals 24. Let's move our 24 over. X squared plus 3x subtract 24 gives you a negative 18. Two sets of parentheses. This is going to be factorable. X times x, positive 6, negative 3. So x is either negative 6 or x is equal to positive 3. Positive odd integers. Can x be negative 6? No, it cannot. Throw it out. X is 3. So therefore, if x is 3, then my next odd integer is 5. So 3 and 5 are your two integers. Number 10, find 3 consecutive positive integers, not odd, not even, but 3 consecutive positives. Your first one would be x, the next one would be 1 more than that, and the next one would be 2 more than the original. So like 5 plus 1, and 5 plus 2 would be like 5, 6, and 7. 3 consecutive positive integers such that the product of the median integer, now median is the middle, the product of the middle integer and the largest integer is 72. So the product of the middle and the largest, that means you're going to multiply them, it would give you 72. What are the 3? Let's clean it up. X times x is x squared. X times 2 and 1 times x gives you 2x and 1x, which is 3x. Then 1 times 2 is 2. Move the 72 over, gives you x squared plus 3x. Subtract 72 gives you minus 70 is equal to 0. Factor. X and x adds, multiplies would be a positive 10 and a negative 7. So therefore, either x is negative 10 or x is equal to 7. However, it does say 3 consecutive positives. So x cannot be negative 10. X is 7. X plus 1 is 8. X plus 2 is 9. And you can check that. The product of the middle and the largest is 72. It does check out.